Communication systems are all around us, from our mobile phones to our car radios. I'm Matt and I'm an applications engineer here at NI-UK, and today I'm going to talk to you about the USRP and the project that we've been working on here.
The objective of the USRP project was to develop an application to teach communications theory to students. A pair of VIs were made, one for transmission and one for reception, to guide the students through each step involved in a communication system. Let's take a look at the hardware that we use to generate and acquire our signals. This is the USRP. We have configured two of these as a very powerful transceiver, which means that it can receive and transmit RF signals. Over the USRP's gigabit Ethernet connection, we send IQ signals to be mixed with an onboard local oscillator for it then to be transmitted. The process is then reversed for reception. So let's take a look at our comm system. In communications, a number of steps are required to transmit and receive data. Firstly, we acquire our data and convert it into a digital format that can be processed by a computer. The simplest way of going about this is taking the representations of our text, images, or live webcam in binary. Once we have our binary data, it is preferable to split the data up into smaller chunks. These are called packets. These packets contain the data being sent in addition to some other components, such as sync and guard bits, which are used to perform error checks and determine packet order. After constructing the packets, the data needs to be converted into a format that the USRP can interpret. This is achieved by applying modulation to our packets to produce IQ data. IQ data is then sent via Ethernet to the USRP, where it is mixed on board with a carrier frequency and output via the antenna. On the receiver, data is continuously acquired whilst the transmission process is enabled. To locate each received packet, the continuous data is filtered for noise and DC offset and then chopped into processable chunks. Each chunk is then converted back into binary representation through the demodulation process. With the binary chunks, we can determine whether a packet was received correctly. This is done by comparing the sync component of each chunk with a predetermined sync pattern. After validating the sync, the message data is extracted from the now known good packet. Finally, we can reconstruct the data back to its original form and display it in our application. Now let's take a look at all of that theory in action. With the project window open, I'm just going to double click on the transmit and receive VIs and open both of those up. With both of those open, I'm going to ensure that both IP addresses of our two USRPs are configured as well as the parameters and start those both running. With the packeting tab, we're going to ensure that packeting actually matches on both VIs so that we're expecting the data that we're sending, and that the modulation type is both set to PSK, also ensuring that the pulse shaping filter is again the same. With the data source, I'm sending text this time. I'm going to start those both transmitting and receiving and type a little hello world message. Once pressing enter on that keyboard, the message is instantly received, and I'm just going to stop those two VIs there. As well as what we've just shown you, we can also send high-res images as well as live webcam over PSK and quadrature amplitude modulation techniques. Thank you for watching. If you're after more information on the USRP project, please follow the links below.